Hey guys, in this video I'm going to talk about how to analyze the symmetries of a polar graph. Analyzing symmetry is something you already know how to do for a rectangular equation and a rectangular graph. You know what's going on with even symmetry, input, opposite input, given the same output, and you know how that works in terms of the algebra, plugging in negative a and getting the exact same output that you get when you plug in regular a. All right, so let's see how that plays out when you're analyzing a polar graph. First, let's take a look at the equation r equals 4 cosine 3 theta. The graph of that equation is shown here. So you can already start to see some of the symmetries that are going on, but let's see, how do you use the algebra to prove that those symmetries are what we think they are? Well, if we use regular theta, of course, we just get normal r as an output. What happens though when we use negative theta? Well, let's take a look. So if you replace theta with negative theta, you get 4 cosine 3 negative theta, which is the same as 4 cosine negative 3 theta. Now we already know something about the symmetries of the cosine function. Cosine of negative theta is the same as cosine regular theta. So these are equivalent based on the symmetry of the cosine function. Well, look what we've got. 4 cosine 3 theta, that's just exactly regular r. So negative theta corresponds also to regular r. All right, now let's kind of connect that to this graph. So if you pick a point, all right, if it's r units from the pole at an angle of theta from the positive x-axis, what this work is showing is that if you do the negative angle corresponding to that, you're also getting that same distance from the pole. All right, so here's the point r negative theta. All right, so we see that this graph is symmetric with respect to the x-axis. Now it also has some other symmetries, so to make sure you understand it, see what happens when you replace theta with theta plus pi. Try to do the algebra and then connect it to what you see in the graph. All right, let's look at one more example. So what about the function r equals 4 sine of 2 theta? Once again, if we just use normal theta, that's going to correspond to r. Let's take a look at what happens when we do negative theta this time. All right, so I replaced theta with negative theta. 2 times negative theta is negative 2 theta, and based on the symmetry of the sine function, we know that sine negative theta is the opposite of sine theta. So this is going to be equivalent to negative 4 sine of 2 theta. Okay, compare. Negative 4 sine 2 theta is just the opposite of 4 sine 2 theta. So this expression is equivalent to the opposite of r, and we've just proved that negative theta corresponds to the opposite of r. All right, how does that play out on the graph? Well, again, if we plot a point at theta r, so r units from the pole forming an angle of theta with the positive x-axis, that's supposed to correspond to, if we take negative theta, okay, this angle down here, that's supposed to correspond to negative r. So we're going to go in the opposite direction by r units. And now we've shown r theta and negative r negative theta. Those points have to correspond on the graph. And so this graph has symmetry with respect to the y-axis. Again, there's way more symmetries that you can look at. See if you can find all of them. Hope this helps you understand the topic of symmetry with polar graphs, and we'll see you next time.